Yeah.
5 motorbike. So actually what it learned is a W that works for both, because I didn't tell the algorithm which are cars.
Which cars, that's right, yeah.
And I have 10 which are discordant, so half of those images have nothing to do with each other.
It's true, but half is still pretty good, right? If you wanted
so
to...
you want me to have 5% and
well,
the rest?
I mean, the other stuff is very robust, but in some sense I want to give it just a lot of images and say, oh yes, it'd be great to learn cars, motorbikes and stuff, even though the majority of things don't really match.
You know, actually, there could be a solution for this, because this algorithm, this learning algorithm, could probably learn only from one pair.
Right.
So one way to do it would be to try each pair differently, learn different W's for each pair, and look at the common W's and keep only those that are common. So for example, on the pairs that it fails, you'll have W's all over the place. And on the pairs that it does well, you'll have similar W's. So then you have a second clustering problem in the W's.
In the same
and
way
you take the average of that, and that could be... Because in all my training, I did, for example, comparison with another learning method that uses 100 images, 100 pairs of images for training, right? So in my case, I'm using only 5. And actually, in some of the cases on the map inference problem, I used only 1. So one or two are enough, and the reason why is enough because this W is a vector, right? But it's appearing in every single possible pairwise score, and you have so many. You have so many that even if you have only one image, because you have so many of those, it generalizes.
So to me, that would feel very unsupervised, right? Because you've really given it, like it's got very little chance. But that's
yes, that would be really that actually it's a very good point. You just throw it 10 categories there and discover the W. That's nice.
Yeah, so about that, there's a minor terminology issue that I've been struggling with, right? It's still completely unsupervised in the sense that the correspondences are not labeled. Right? And from a practical standpoint, that's a very important consideration, right? Because labeling the correspondences is impossible.
That's right.
So even if the images are labeled, like you can think of it as
loosely labeled.
You still have the correspondences are completely unlabeled. Right? So there's kind of two levels of supervision, and you're talking about the second level. So there's a terminology issue that is still not working very well. So.
There is a terminology issue, but the experiments I showed is unsupervised at both levels because I have cars and motorbikes. Of course, what you're talking about is expanding this to a higher, to a larger scale. Instead of having only cars and motorbikes, how about having all these different and try to see...
The chance of finding a dominant cluster, if you just pick 2 random ones right now, is still pretty high, whereas if I just grab 2 images from the web, in general, there'd be very few over there. But in your case, you're saying that even if I found a few that are consistent, you'd have enough to build up.
We can do this, what I said, only use one pair, and if it fails, and also you can see when it fails. It fails when the Eigen vector does not become binary.
It doesn't like to be binary, right? So
that's another way of seeing the failure cases. Also, there is another thing, even if you have images that do not contain the same category, they might contain stuff that looks similar. And the algorithm will tend to grab those and actually learn something that's meaningful. Because even if I show you a motorbike and a car, right? They are not similar, but you still have the wheels, you still have some straight lines, you still have some rectangles. It automatically tends to find things that look similar, even though they belong to different, the level of category, they belong to different objects.
Okay, so I just asked one other quick one then. So in chapter 8, again, kind of the perceptual grouping.